Guys, how's it going? Today I want to talk about section 8.5. It's called factoring special products. So the idea basically here is factoring can be kind of a time-consuming, tedious process sometimes, especially if you're dealing with some larger numbers or numbers that have multiple factors like 24, where you run into 1 and 24, 2, 12, 3, 8, 4, 6. It just becomes a lot to guess and check, so to speak. So today, basically what we're dealing with are two special products that you want to kind of keep an eye out for, because if you recognize the special ones, it becomes really, really easy to factor. Okay. But recognition is kind of the biggest key. So if you recognize some of the easy ones, it can just make your life really easy sometimes. So the two we're going to talk about are called perfect square trinomials and then a difference of two squares. Okay. So the perfect square trinomial comes from basically this, okay, where you have 3x plus 4 squared, or 3x plus 4 times 3x plus 4, okay? So I'm kind of working this one backwards. So the goal here is to get back to something nice and pretty like this, okay? When we FOIL this out, we get 3x times 3x is 9x squared. 3x times 4 is 12x. 4 times 3x is 12x again. And then we get 16, right? So what that combines to become is 9x squared plus 24x plus 16. This is an example of a perfect square trinomial, okay? Now, the reason we call it a perfect square trinomial is, I spelled that wrong. It's a trinomial because it has 1, 2, 3 terms, but it came from a perfect square where something got squared. So the question becomes, how do I recognize when I see this? How do I recognize that this is a perfect square? Okay. Well, the first thing you want to look at are the first term and the last term, okay? That 9x squared and the 16. Those two numbers have to be perfect squares, okay? Because basically 3x times 3x, or 3x squared, gets you that 9x squared, and the 16 is 4 times 4. So if you see that, that's going to be your first indicator. Are those two numbers perfect squares? If they are, there's a quick check to see, is this in fact a perfect square trinomial? So now what we want to look at is that middle term, that 24. Well, where did that 24 come from? Well, it came from the two 12s added together. But where did the two 12s come from? The 12s came from the 3x and the 4 when you multiply it. So basically what I like doing is I just think of, all right, if I have basically 3x and 3x, and I have 4 and 4. If I take 3x and times it by 4, and then double that, okay? And the reason we double it is because there's always going to be two of those. If this gives you that 24, then you definitely have a perfect square trinomial. So the question just becomes, you look at the first term, is that a perfect square? Yes, cool. Is the last term a perfect square? Yes, cool. Okay, so now we have a quick check to see, is this a perfect square trinomial? All you do is multiply what the root here and the root here, multiply those together, times it by 2. If that gets you to that middle term, then you know this is a perfect square trinomial. And then what it's going to end up factoring back into is the 3x. That's positive 4, and you square it, and you're done. Like, that's really what the answer is going to be. So it takes all the guess and check out of it. It basically is a quick check, okay? I mean, it is important to notice this isn't going to work all the time. It's just a quick check to see if it will work. So let's try a few examples. All right, x squared. Well, that's a perfect square because x times x gives me my x squared. 36, sure enough, 6 times 6, right? So we just take those two numbers, the 6 and the x, times them together, and then double it. Does that get you to that middle term? Sure enough, the answer is yes. So yes, we know this is a perfect square trinomial, which means it's going to factor into, you're going to have an x, you're going to have, that's a positive 36, so it's going to be a positive 6, okay? And it's going to be squared. Or, I mean, if you wrote x plus 6 times x plus 6, either one of those two answers is correct. I like writing the quantity squared because it means the same thing. It really is that simple. It's the idea here is this going to be something that can make your life a little easier sometimes? That's really the goal, okay? Now, it is important to notice, like in this one, both of these signs were positive, which told me I knew my two signs were going to be positive, okay? The one thing we have to be conscious of is when you take the square root of 36, that's kind of how I got that 6, right? 6 times 6 is 36. Well, technically, all square roots have two answers because 6 times 6 works to get to 36, but also negative 6 times negative 6 works, all right? So the question becomes, how do I get, how do I decide is it positive or is it negative 6? Well, in this one, both signs were positive, so I knew my sign had to be positive. In this one, I mean, looking at the signs, I know they're going to be the same, but they're going to be negative because of this one. So again, it's just a quick check. Is this a perfect square trinomial? 4x squared, well, sure enough, yep, 2x and 2x multiplies together to get to there. 9 would be 3 times 3, or negative 3 times negative 3, right? So the question is, can I get to that 12? Well, if I multiply those together, the 2x and the 3, and then double it. Again, you always got to remember to double it. 2x times 3 is 6x. 6x times 2, sure enough, gets me to that 12x. So yes, this is a perfect square trinomial. So if you want to write it twice, I know it's going to be 2x and 3. I know it's going to be 2x and 3. My signs are the same. They both have to be negative. Or you could have just written 2x minus 3 squared. So the idea here is to make your life easier. Again, not everything is going to work. Not every trinomial is a perfect square trinomial. Even if you see, yeah, x times x, that works. 16, sure, 4 times 4. But if I try to check that middle term, 4 times x, and then I double it, that does not get me to that 9. So this is not a perfect square trinomial. So I would have to check other ways to factor. So then the next thing I would have to do is keep going back through, and say, all right, how do I get to a 16? 1 times 16, 2 and 8. All right, 4 and 4. I got to go back to my old method, and this one actually doesn't factor. So don't think just because you see perfect squares that sure enough that this is going to be a perfect square trinomial. It's just a quick check. Maybe it'll work, maybe it won't. And sometimes, especially if you're dealing with some large numbers, I don't want to list a lot of factors. I'm looking for, is there a shortcut? Is there something that I can do to make this a little bit faster? Well, I look at these and go, oh, 5x, 5x. Let's try that one first. And 7 and 7, that works nicely. Fingers crossed, is this a perfect square trinomial? Well, 5x times 7, that's 35x. And then I double that. Sure enough, yep, it gets me to 70x. I know I'm done, basically, because it's going to be 5x and 7. 5x and 7. Both sides are the same. They're both negative. And then 5x minus 7 squared. Now, it is worth noting that if you ever run into something that has a negative sign right before the last term, if this sign is a negative, okay? It'll never be a perfect square trinomial. I might still be able to factor it. Okay? I might still be able to list all the factors and find a combination that'll subtract to get to 70. That might be possible, but it'll never be a perfect square trinomial. Okay? This sign has to be a positive because the positive means both sides are the same, and that's kind of the idea. I'm looking for the same thing twice. Okay? All right, so those are perfect square trinomials. Again, it's just a quick check. Maybe it's going to work, maybe it's not. We're just looking for some shortcuts, okay? Now let's talk about difference of two squares. Difference of two squares is actually really easy to recognize because what you're looking for is perfect square, okay? Perfect square, where x times x, is x squared. You're looking for perfect square, okay? Again, 9 times 9, 81. And difference means subtraction, okay? Has to be subtraction. If that is the case, then it's going to factor immediately into x and 9, x and 9. You will have one positive sign and you will have one negative sign. You are done factoring. The reason this works is if you FOIL this back out, okay, you'll get x squared, x times x is x squared. You'll get a negative 9x when you do the outsides in this case. And then when I do the insides, I get a positive 9x. And then positive times a negative 9 would be a negative 81. What will always happen, because the positive and the negative, and they're the same, the middle terms will end up canceling each other out, leaving me with just the x squared minus the 81. So perfect square trinomials are super easy to recognize, and they're really easy to factor as well. So, x squared minus 9, sure enough, 4x squared. Well, square root of that, 2x and 2x, right? Well, 2x times 2x is 4x. 9, 3 and 3. Great. And it's minus. Sweet, it works. The answer is 2x plus 3. 2x minus 3. You're done. You can deal with bigger exponents as well, as long as they're even, because it's got to be even for you to take the square root. Sure enough, 9x to the fourth would be 3x squared times 3x squared. 16y to the second would be 4y times 4y, right? So, because it's minus, sure enough, difference of two squares, the answer would just be 3x squared plus 4y, 3x squared minus 4y, okay? But again, it has to be a number that you can evenly take the square root of in both the first and the second, and it has to be a minus. If it's plus, it's not going to work, okay? And the reason it won't work if it's a plus is if these were both plus, we would have ended up with a positive 9 and a positive 9. They're not going to end up canceling out. Plus, a plus and a plus can't multiply together to get a negative 81. And a negative and a negative can't multiply together to get a negative 81. So it has to be one of each, okay? So that has to be a negative. So if you see something like x squared plus 9, there's nothing you can do. That is factored all the way. If you see odd exponents, this has an exponent of 1, that has an exponent of 3, you're done. That's not a difference of two squares. There's nothing you can do there, okay? So it has to be something like 36 x to the fourth. This has to be a perfect square. You have to have an even. It has to be a minus. It has to be something like 81, because that's a perfect square. And you could have a y to the 8th, as long as these are even. Great. Perfect square, I can take the square root of that. Perfect square, I can take the square root of that. It's minus. That means the answer, the square root of that would be 6x squared. The square root of this would be 9y to the fourth. So you're just going to have 6x squared plus 9y to the fourth, 6x squared minus 9y to the fourth. And you're done. Again, the idea here is quick, easy, shortcuts, things to recognize them when you see them kind of thing. So give a few of these a try and let me know how it works out. I'll talk to you guys later.